So now we move on to the confidence interval of the proportion. Okay, so what do we mean by that? Here we have the mean. The mean, as we said in the last video, we calculate the mean of every 10 values, 10 sampling of values for the trimesters. Okay, and then what we're gonna do now is gonna calculate the proportion of evolution. Okay, so what we do is we take the mean of the mean called the mean of reference. Okay, to calculate the evolution we have formula for that. It's T1, which is the value here, minus T0 V0, which is the value of reference, divided by V0, which means divided by the value of the value of reference, multiply by 100. It gives you an evolution. For example, here we have L2, which is 224.8, and the mean of reference we have V0 in all of these values is 165. Okay, is L2 minus 165 divided by 165 gives you the multiply by 100. It gives you 36.24%. Same here, same thing. Okay, what we're gonna do is gonna take the mean of proportion evolution, and we're gonna calculate the mean of it. I'm gonna remake it here. I'm gonna select all of that. It's 6.77%. Okay, now what we're gonna do is we're gonna move on to our programming language to calculate the confidence interval of the proportion, where the values at the level of confidence of 95%, where is most frequent evolutions. Okay, now here we have we already did that. Same process. I'm gonna explain this with pen and paper. Confidence interval of the proportion here we have P, which is we have here 6.77. Now, what to calculate we need the norm. Also, we're gonna approximate it to the normal distribution. Okay, so we have here 6.77. Now we're gonna move on. The formula is very simple. Just we make the average proportion. Then we're gonna calculate the margin of error. The margin of error, we have a unique formula for that. It's the key norm distribution that I already explained. Is 1975 because we approximate the level of confidence of 95%. So we have here key norm, which is approximately I think it's key norm of 1970 of 0.1975 is 1.96. Key norm. So multiply by So what we have here, it's key norm distribution multiplied by make attention to that. It's square root of p multiplied by 100 minus that p, which is 100 minus 6.77 divided by n. N, it's number of number of all values that we calculated here. We're gonna call here number. You can select that that. It's 21, okay? So square, as we said, square .77 multiplied by 100 multiplied by 100 minus we calculate primarily that 100 minus 6.77. It gives you 93.22. Divided by the number that we have is 21. Now what we have here, it's we're gonna calculate the extreme inferior value of the evolved proportion, then extreme superior value. P minus error P plus error. Now what we have here, it's so the evolution of average of price of action compared to the price of reference of 167 vary between minus 3.97% and 70.51% at the level of confidence of 95%.